For Unit 6, Lesson 5, we will be discussing reaction mechanisms. When we look at a balanced chemical equation, we are just getting the beginning and the ending of a reaction. But most reactions take place in many smaller steps. These smaller steps we call the reaction mechanism. They're a series of elementary steps that take place over a complex reaction. For the individual steps of a reaction mechanism, we can determine the step's molecularity, which is the number of molecules that come together and react. If there is only one reactant, we call it unimolecular. If there are two, we call it bimolecular, and if there are three, we call it termolecular. Looking at a reaction mechanism, we can identify any intermediates. These are substances produced first as a product and then used in a later step in the mechanism. In this example, we have two intermediates, N2O2, which is produced in the first step, and N2O, which is produced in the second step. You can also identify catalysts by looking at the reaction mechanism. These are species that first appear as a reactant in the first step and then are reproduced as a product in the last step. In this example, substance B is the catalyst. You see it first as a reactant and then reproduced as a product at the end. We can use the reaction mechanism to get the overall reaction. All we need to do is add together the elementary steps, making sure to cancel anything that appears on both sides of our reaction. The rate law can be determined easily by looking at the reaction mechanism. It is determined by the coefficients of the elementary step that is the slowest. On this example, step 2 is listed as the slowest step. Both of our reactants, N2O2 and H2, have a coefficient of 1, so the order for both of them is 1. For example number 1, we are first asked to determine the molecularity of each step. Step 1 has one reactant, making it unimolecular. Step 2 has two reactants, making it bimolecular. Question 2 asks us to identify the overall reaction. First, we want to cancel out anything that appears on both sides and then add them together. Next, let's identify our intermediate. This is a substance that is produced first and then used in the next step. In this example, O would be our intermediate. Then let's identify any catalysts. Remember, catalysts are used first and then reproduced at the end. This reaction has no catalysts. For question number 5, we want to determine our rate law if step 2 is our slow step. The two reactants listed are O3 and O. Both of them have a coefficient of 1, making them both have an order of 1. Pause the video and see if you can try example number 2 on your own. For example number 3, we want to determine what are the relative rates of our steps in our reaction mechanism. Now the slow step is going to be determined by the one that matches our rate law. Step number 1 has the same reactants as the rate law. This will be the slow step, meaning step number 2 is the fast step. Pause the video and see if you can try example number 4 on your own. We can also visualize reaction mechanisms by looking at our potential energy diagrams. This diagram shows 3 peaks, meaning our reaction mechanism has 3 elementary steps. The one with the largest activation energy, or the largest hill, will be the slow step. Pause the video and see if you can answer questions for example number 5.